Hello and welcome to another video of machine learning do-it-yourself tutorials. In this video, we're going to talk about how to evaluate model performance. Please note that in the previous video, we were able to design or create a linear regression model using R. So what did we do actually there? What did we try to achieve? So from a mathematical standpoint, this is what we tried. We had spend and income as two attributes, and we plotted the actual available data in the graph. And please note that the black dots are actual values. Next, we trained the model and created a linear regression model, obviously. And imagine a linear regression model is a line, a slope, which encompasses multiple values, and the other values may or may not fall in the same line. Please note that there are majority of the values fall on the line, but there are some values on the left hand side or the upper side or the down side of this line. The difference between this line here and the value here is the error. What it means is, based on the equation, the value should be lying somewhere here, but the actual value is here, and this is what the error of the model would be. So in order to do an understanding on linear regression model, draw a line, and that would be your equation. Remember our mathematical formula on slope: y equals mx plus b, where m and b are constant, and the value of y, which is spend, is going to vary with the value of income. It may not be a perfect variable or perfect equation, but this is the line which we are talking about. This is the slope. Once you have the data plotted and the model trained, then we will ask the model to predict the values for us. It's all mathematical. And these values with the red colors are the predicted values. As I mentioned earlier, for this actual value, the predicted value could be here. Difference between the actual and the predicted value is the error on the model. In order to understand and evaluate the model, there are two KPIs, which are key performance indicators of the model associated with it. First is root mean square deviation. It is the square root of the mean of the difference in actual and the predicted value. We're going to talk about more in detail on root mean square deviation or error in the next video. And R squared, this is a scale of 0 to 1, which tells you how confident my model is on the prediction. It can rate or score anywhere between 0 to 1, and you would want the value closer to 1, which means the model is really confident. However, if you have a value which is 1, that means you are no longer doing a model, you are a god, because you know what would be the predicted value. So ideally the value may not be 1 all the time. It should be 60s, 70s, 80s, 90s, depending upon what the data is for a particular model. Based on the data, even if the model remains the constant, the data can drive the values of root mean square deviation or error and R squared up and down. We will see these KPIs more in detail in the next video. Thank you for watching.